Yeah, hi everyone. This is Mayur, and this is my final pitch for the hackathon, Blue Planet Hackathon. So, basically, in this hackathon, I would like to solve this problem under this theme, forest conservation. So, we shall begin. So, first, I would like to tell you about myself. I am Mayuresh Bharmoria, and I work in Bangalore. And when I started working on this hackathon, I was not sure what I will build. But as I worked more on more, and the ideas seem more clear to me. So, what is my idea? So, my idea here is to use the dataset provided by local government and various agencies, forest agencies, and I visualize that data, and I've also built a machine learning deep learning model that can help to categorize the forest area, and it can help you to categorize whether the afforestation or that land is suitable for planting trees or not. So basically, when you search for forest data, then you will get this data.gov.in, and you'll get the data set of about district wise forest, that is in each state there is a district and how much is the forest area in that district. So when you download this data set with each state, it will be information like this, like how many districts are there in Maharashtra, and each information like this. These will be the CSV files. So there will be like 600 districts total, and there will be like thousands of records. So what I've done is I've collected all this information, and I have put it in a visualization format so it can be easily understood by people, that how much is the which district is having the highest density of forest, and like that. So this is the exactly field. This census was done by Forest Department on 2013. So as you know, after 2013 there is a major shift in different states. There are different districts have formed, and like that new territories have formed. And this is the main. Let me minimize this one. So this is the visualization of the dataset. I have used the Google API, and after getting the Google API, and I have extracted the data from this website. This is like a open GIS website where you get GIS information of latitudes and longitudes. So I have scrapped the data, you can say, from this website, and this is the boundary of a polygon that forms a district. So I'll know that this is the area of a district, and from this data set I'll know which district in each state is the highest forest concentration of the forest is highest, and I have plot this whole thing on the Google map. And now I know that which district, these are the boundaries of district. So as you can see, there are few districts missing because some of the data in open data sets are not there. But there are more than 400 districts, and let's say Telangana is not there because in 2013 it was not there. So in this way, this census helps me to visualize which state is like in desperate need of forestation and all. So moving on to the next slide. So this is the CSV, and it helps to categorize it in a most visual format. So after doing this, I thought of using a deep learning framework that can help to like do the census itself. Now I know in each district where the boundaries are, and within each district I can just take this latitude and longitude of this area, and I will take a photo of this area, then I'll take a photo of next area. In this way I will generate a next latitude and adjacent latitude and longitude, and I will download the photos of whole district. And I have done here is let's say this is the place where I live and work. So what I've done is I have put the latitude and longitude in my algorithm, and I have taken the snapshot of this area and snapshot of next area and the snapshot of next area. In this way the whole district area is downloaded. So this is the like file, this is the square, this circle building you can see, and this is the 3x that is in the next image, like this, these 3 axes. So in this way I have collected thousands of images, and I have trained a deep learning model that is built on TensorFlow, and then let me open this one. So the deep learning model that I have trained is able to classify these 8 classes. This is tree, like whether there is a trees, there a single tree, a bunch of trees, and wasteland. Wasteland in particular is, let's say this area is an example of wasteland. It doesn't have any building, it doesn't have any fields, or it's not even cultivation, used for cultivation. So we can plant trees here. So yeah, this is the slide. So I am also able to detect the building that can help us to detect the human population within an area, and with the help of that we can raise awareness and build a local community groups that can plant some trees. So the main important thing, help of this the GIS system that I built here, is that we can even track the progress of previous previous forest, and how many trees are still there, or what is the effect of growing population or growing buildings within the area with respect to the forest, and trees in the nearby area. And I have also built a class that can detect water. So water is very necessary for afforestation and planting more trees. And this field basically detects the cultivatable land. So if it is beneficial to decide whether this land is fertile and used for cultivation, or this land is not used for cultivation. And obviously forest and bushes. Forest generally spans a more wider area, and bushes are the bunch of trees that are located and are not like this is example of a bushes, and this is not like a tree, either because of shadow of the satellite or the size of the tree is very small, so we cannot 100% say it is a tree. It might be a small bush or something. So in this way I have trained the deep learning model on the thousands of images. So I'll show you a brief training images that I have selected. So this is the model being trained, and this is the inference graph that shows the accuracy. So as you can see, the loss is going to plateau out, so it is going to become a straight line. So I have stopped it there and I have tested on that. So I will show you a demo. So it's trained on thousands of images that I have labeled, and now it will show you what it has, the result any second now. So it's able to detect these are trees, these are fields, and this is also a tree. So these are bushes. That can be anything human planted, like field of for livestock or something. So in this way this GIS tool that I built, that can help people to launch awareness campaigns. How green is your district, how green is your quadrant. Like given a latitude or longitude of 1 point, it can take 4 photos of 5 kilometer or 2 kilometer area, and it can help people decide whether, let's say, this is the possible area for plant cultivation, or this is like a water, and things like that. So it's trained on satellite images, but we can do the same thing with drone and drones footage and satellites we can use. So moving on to the next slide. So this is the image I have shown. This is the place I work. So this is like a wasteland. it is pretty good. It's near a human population, so we can go there and plant trees also. Let me run it on something else. Yeah, this image will find. Generally these GIS tools are very huge in size, of like petabytes to terabytes they scale. So what I've tried is like build a model that can be scaled, but in current scenario it is not that big. So this is like a building, it has detected a single tree, this is also tree, and this is also building, and these are also fields. So in this image detection problem, it is very difficult to classify because there will be like thousands and thousands of cases. There can be an airport, that can be square, rectangular, circle, or most importantly, let's say water. It can be green, it can be gray, it can be blue. So it was very difficult, and I finally shown something and I built, and so that's about it. So did I mention this in this image? The more green the state will be, the more forest population, forest density is there in that state. So in this way you can see your state. There is even labels we can remove, just like see the shape, and this is like a terrain. So this way you can see that what is exactly happening. So that's about it. So thank you. I have not explained this slide, so it's just basically to detect and navigate through and get like next coordinate. This is the information of the, let's say, latitude and longitude of each district. This XML is passed by this JavaScript website, and then it shows the like district boundary. So after getting the district boundary, I'll get a latitude, I'll give it a latitude and longitude, and it will detect whether the next point that is generated to the right, left, or north, south, it is within the boundaries or not. So in this way, this data that is collected by government, that can be automated, and we don't have to wait for the next census to occur. So we can automatically build something that can automatically classify how many trees are there, and how much is the density, or how much square kilometer of the forest area is used or not. So there are a lot of potential use cases that will come out of this this project. So basically we can also detect what is the output of the last of afforestation camp or something, or how much is a population affecting the nearby area, and things like that. So that's about it. Thank you and have a nice day.